Am I audible? Yes.
Okay.
Very good afternoon, my dear friends. Welcome to the session in the regarding of CPGET free online coaching. Today is our eminent resource person, Dr.A.SHAILAJA Madam Garu, Assistant Professor, Department of Botany, Government Degree College, SIDDIPET, Autonomous. Madam, please welcome. Start your session and share your screen. Madam is going to explain about the sporophytic evolution in bryophytes. It is most important in all the competitive exams regarding of our CPGET 2024 also. So, my dear friends, listen carefully. Madam, please welcome. Madam, your voice is not audible. Madam. Hello. Hello, madam.
Sir, my voice
Yeah.
is audible?
Yes, your voice is audible. Please click on slideshow.
Good afternoon, sir.
Okay, madam. Slideshow. Click చేయండి స్లైడ్ షో పెట్టండి.
Naina?
Ma'am.
Madam, your screen is visible.
Are
Please
you there?
click on
My
slide
voice
show.
is clear?
Yes, ma'am. Your voice is clear only.
Slide show పెట్టండి madam. Click on slides.
This meeting is being recorded.
Evolution of sporophyte in bryophytes. It's very
Evolution of sporophyte in bryophytes is a very important topic.
Class. సార్ నా వాయిస్ నాకే వినబడుతుంది, డబల్ వస్తుందండి. వినబడట్లేదు. అయితే ఏమైంది అని అంటే అది సిస్టమ్ వాల్యూమ్ రావట్లేదు. సో నేను మళ్ళీ మొబైల్లో జాయిన్ అయ్యేసరికి అది ఇది రీసౌండ్ వస్తుందా, నాకేం అర్థం కావట్లేదు. ఒక్క నిమిషం.
Hello. Madam, please proceed.
Okay, sir. So, good afternoon, my dear students. Today's our topic is evolution of sporophyte in bryophyta. This is a very important topic. To explain this evolution of sporophyte in bryophytes, there are two important theories. That is theory of progressive evolution and retrogressive theory of evolution. Okay. So, first I will explain that first theory of progressive evolution. Okay. So in this theory was first proposed by Bauer and was supported by Cavers and Campbell. It's very important. Please note down these scientists' names. Theory of progressive evolution. So what is the evolution? What are the changes we are observed in the Bryophyta sporophytic structure? Okay. This theory was first proposed by Bauer and was supported by Cavers and Campbell. According to this theory, evolution has taken place from simple Bryophyta to complex Bryophyta plants. So we are observed that structure of sporophyte in different plants. So these, according to this progressive theory, has taken place from simple Bryophyta to complex Bryophyta plants. See here, this means that the sporophyte of primitive Bryophyta members is simple. Okay, so what is that? That is the primitive Bryophyta members is simple and that of advanced Bryophyta members is complex. Please note down this point. What is that? That the sporophyte of primitive Bryophyta members is simple and that of where is the advanced Bryophyta members is complex. Okay. So according to this theory, that evolution has taken place from simple to complex type. Okay. What is the simple method? What is the simple? Primitive Bryophyta members are called simple. Advanced Bryophyta members is the complex. So next one, see here. So first one is the Carcinia. See here, foot, seta and a capsule. Carcinia, which belongs to Carciniaceae family, is more evolved than the Rixia. Okay, Rixia. So what is that? That Carcinia, it is the one type of one genus belongs to Bryophyta, which belongs to Carciniaceae family, is more evolved than Rixia. Carcinia sporophyte consists of a capsule and a sterile tissue at the base of the capsule, which is considered as a foot but has no seta. Okay. So, but in this diagram, seta will be shown, but seta is absent, no seta. Okay. So only foot and capsule are present in the Carcinia. See here. So we are coming to the second sporophyte, that is Rixia. So see here, the sporophyte is small, simple and evolutionary very primitive. Evolutionarily very primitive. The sporophyte consists of only a capsule, foot and seta are absent. Actually, this is a evolutionary this is very primitive. Rixia is the very primitive. Actually, this first is the first place is the Rixia. So see here in the Rixia, that the sporophyte is very small and very simple and evolutionarily very primitive. So these consists of only, the sporophyte consists of only a capsule. See here, foot and seta are absent. This is the only capsule. So the capsule is completely embedded in gametophytic tissue and absorb the nutrients. It is devoid of chlorophyllous tissue. So Rixia sporophyte lives as a complete parasite. Okay, so these embedded in the gametophytic tissue and absorb the nutrients from the gametophyte. That's why this sporophyte is a complete parasite. Okay, this is a dependent on the gametophyte. That's why we are called a parasite. This is the Rixia sporophyte. Okay, this is a jacket that is we are called amphibium and nurse cell and a spore mother cell. And this is a venter in the archegonium structure. These will be formed in the archegonium venter. Okay, so that is the sporophyte of Rixia. Okay, so this is very primitive. Next, come to the another one, that is Spirocarpus sporophyte. So these are the different genus belongs to Bryophyta members. So Spirocarpus sporophyte shows a bulbous foot, a short seta and a capsule. See here, bulbous foot and a very short seta and a capsule. Okay, so in this capsule develops archisporium of the sterile nutritive cells along with the functional spores. Thus, at the reduction time, that the spores are coming to the haploid. So, next in the family of Markantiales, see here, this is the Spirocarpus. So, in the Spirocarpus, we are observed the three parts: bulbous foot, short seta, and a capsule. So, next in the family of Markantiales, same already in the Markantia sporophyte we have seen that what is that foot, seta, capsule are present in the Markantia. Already you know what is about the Markantia sporophyte. Okay. Next is the Stargionia sporophyte, which is a member of Stargioniaceae family, comprises a foot, two cell thick seta, and a capsule. In the Stargionia, we are observed that the foot is comprises of a foot and a two-celled thickness of seta and a capsule. That is the Stargionia. And nearly half of the sporogenous of archisporial cells in the capsule form the sterile spiral elaters. Okay. So in the Markantia also we are observed the elaters, spiral elaters. These are hygroscopic in nature, and at the time of the spores dispersal, that helps in the dispersal of the spores. So these elaters helps in the spores dispersal. Okay. So Spirocarpus and Markantia and Targionia, these three members as same. Okay, foot, seta, and a capsule. See here, this is the already we know that this is about Markantia sporophyte. Role of seta is also very significant in the spore dispersal along with elaters. The elaters absorb the water and helps in digestion of the capsule. The seta is short in the early stages of the sporophyte and elongates at maturity. The seta first at the primitive stage, that is early stage, that is very short. After the development of sporophyte, it elongates at the maturity time. Okay. So it ruptures and calyptra and pseudoperions to bring out the capsule. These are the calyptra, pseudoperions are observed in the Markantia sporophyte. At the spores dispersal time, it ruptures. The calyptra and pseudoperions ruptures to bring out the capsule. So from the capsule wall also rupture, and the spores released from the capsule. This is about the Markantia. This is the spore and elaters. So these are long linear special structures are called elaters. Okay. This is about the Markantia. See here, this is the Pellia sporophyte. What is the special of this? Elatophore is present in the Pellia, which belongs to Gengermaniales, shows further evolved sporophyte. I am explaining you what are the evolutions are observed in the Bryophyta members, different genuses. Okay. So this Pellia, which belongs to Gengermaniales, it shows further evolved sporophyte. The sporophyte is differentiated into foot, seta, and capsule. Capsule wall is 2 or more layers thick. See here, this is the capsule, and the foot, seta, below the foot, that foot involucre is present. So at the capsule base of the capsule, we are observed that some are all are elaters gathered at one place. That is, we are called elatophore. Okay, that is the special thing of Pellia. So at the base of the capsule, see here, at the base of the capsule, some of the archisporial cells become sterile, forming the structures with spiral thickenings. This is called elatophore. That is the special character of Pellia. Okay. These structures helps in the spore dispersal. Elaters or elatophore, pseudoelaters, all are helps in the spore dispersal. Remember that. Okay. The seta of the mature sporophyte is short and elongates at maturity. Because of the sudden growth of the seta, the capsule ruptures the calyptra and pseudoperions and emerges outward. The capsule dices into 4 walls. So then the spores are released from the capsule. This is about the Pellia sporophyte. Okay. This is about the progressive theory. So who is given the progressive theory? Scientist name? Please tell me anyone. Progressive theory is given by?
What, ma'am?
Scientist name, progressive theory. We are learning about the progressive theory, no?
Progressive theory.
Progressive theory.
Okay, okay. Progressive evolution, no, ma'am.
Evolution means this is a one theory. Okay, theory of progressive evolution. Okay, so two theories are there.
Boyle.
Bauer. Okay, Bauer in the year 1908. This is supported by Cavers and Campbell. Okay, so according to this theory, it is progressive means it is that evolution has taken place from the simple to complex. Okay, are you understood? These are very important. This
Yes,
theory
ma'am.
was
Yes,
supported
ma'am.
by Bauer and it was supported by Cavers and Campbell. According to this theory, that evolution has taken place from the simple to complex. Okay, that this means that sporophyte of primitive bryophyta members are simple and the advanced bryophyta members are complex. Okay, so that's why we are this is the Rixia. In the Rixia sporophyte, we are observed that food seta are absent, only capsule is there. Okay, that is the functional capsule is only petal. Food seta are absent. So next one is the Spirocarpus. Please mute yourself. Okay. Next one is the Spirocarpus. Nitya, please mute yourself, Nana. Nitya. Okay. Next one is the Spirocarpus. This Spirocarpus sporophyte shows bulbous foot and short seta and capsule. So these capsule develops the archisporium of the sterile nutritive cells along with the functional spores in the capsule. So next family Markantiales and after that Targionia. So this is about the Markantia sporophyte. Already learned this one at the type study of Markantia. Okay, so this one is a new one. This Celia. Actually, this belongs to Zengermoniales order. It shows further evolved sporophyte. It differentiated also food, seta, and capsule. But capsule wall is 2 or more layers thick. Okay, we are observed before that only the capsule wall is single cell thickness. But here that Pelia capsule wall is 2 or more layers thick. At the base of the capsule, some of archisporial cells are become sterile and forming the structures with spiral thickening. Those are called electrophore. Electrophore present at the base of the capsule. See here, ఇక్కడ మీకు diagram లో కనిపిస్తుంది చూడండి. So bulkyగా group form అవుతాయి. That is, elators are group is formed as a group that is called electrophore. Okay, these structures help in the spore dispersal. The seta of the immature sporophyte is short and elongates at maturity. Because if this sudden growth of the seta, the capsule ruptures the coleoptera and pseudoperion and emerges outward. The capsule dices into 4 walls. That is about the Pelia sporophyte. Okay. Next one is the, see here, this is the Anthoceras. Already we have discussed in the last class that in the Anthoceras type study, which belongs to Anthoceratopsida, the sporophyte shows much more sterility in the archisporium. Sterile cells convert into pseudo-elaters. See here, what are the sterile cells convert into pseudo-elaters in the Anthoceras? Okay, this helps in the spore dispersal. Endothecium of the capsule completely turns into sterile columella. See here, we are observed that sterile columella is there in the center of the capsule. At the base of the capsule, what is the specialty of Anthoceras? Anybody? Food seta capsule is the common. Same structures are we are observed in the Anthoceras. Is it true?
Ma'am?
Anthoceras sporophyte structure, we are observed the food seta capsule. Is it true or false?
False, ma'am.
Okay, good. What you observed?
In food seta capsule, there is no Anthoceras, no, ma'am.
What is the special thing? What is that?
Ma'am, what you are asking, I can't understand.
Anthoceras sporophyte, what are the parts?
What are the parts you are asking, ma'am?
Yeah.
In this diagram, ma'am.
Yeah. Anthoceras sporophyte. This diagram belongs to Anthoceras sporophyte, na?
Yes, ma'am.
What the parts you observed?
Ma'am,
Mainly,
that
this
letters I
sporophytic
can't see, ma'am. Once zoom, no, ma'am.
Why you are having that letters? You don't know about the Anthoceras?
I know, ma'am.
Already 2 days back we are discussed, na?
Yes, ma'am.
Fourth theta capsule. Theta is absent in the Anthoceras. Meristematic tissue is present. Okay?
Yes, ma'am. Yes.
Yes, ma'am. ఇప్పుడు గుర్తొచ్చిందా? Okay. That is the special. Fourth, at the place of theta, that is meristematic tissue is present, and a capsule, which leads to indefinite growth in the sporophyte. The wall layers of the capsule consist of chloroplast cells. Therefore, the sporophyte of Anthoceras lives partially independent of its gametophyte. This Anthoceras sporophyte has foot and capsule and is divided of theta. Because of that, at the theta place, meristematic tissue is present. Okay? So see here, these two diagrams belongs to funaria and this one. This one belongs to? Please tell me.
Ma'am, these two diagrams belongs to funaria only.
No. I am asking that this above one is the funaria. Okay? This funaria you have in the intersyllabus. This diagram belongs to which one? I am asking you.
Ma'am, in intersyllabus in botany, this is having a ma'am.
Yeah, funaria having in the inter. But
no,
below
ma'am,
one,
it
below
not
one.
having.
Below one, which one? I am asking you.
Wait, I'm telling.
Anyone. The yesterday's class we are discussed that. What happened? Nitya? Mahaveen, Nafis Sultana, anyone?
Ma'am.
Naina, tell me.
Ma'am, the diagram belongs to, I think, so pericycle, na ma'am? Pericycle.
Yesterday class you are there? In the yesterday's
Yes.
class?
Yes, ma'am.
Which one you learned in the yesterday's class? That is the BRYOPHYTA member.
BRYOPHYTA member, ma'am. Ma'am, I'm thinking that is pericycle.
What is pericycle? That is one of the sporophyte.
Okay, ma'am.
Markantia sporophyte, Anthoceras sporophyte, or polytrichum sporophyte. I'm asking you. The diagram belongs to which BRYOPHYTA member? Already given that clue. It is a BRYOPHYTA member.
Polytrichum.
Very good. Everamma cheppindi intasepatki. Polytrichum. In the last class. Polytrichum kada manam full ga నేర్చుకుంది.
Yes, ma'am. Yes.
మరి అలా ఎలా మర్చిపోతారమ్మా నిన్నటికి వాళ్ళకి ఇంత కష్టపడి చెప్పి కూడా వేస్ట్ కదా.
I written notes also, ma'am. I forgot that.
Forgot. Okay. So this is a very complex structure of sporophyte in the BRYOPHYTA members like funaria and polytrichum. ఈ స్లైడ్ లోనే ఉంది ఇంత నీట్ గా. అయినా కూడా మీరు చెప్పలేకపోయారు చూడండి. So in the BRYOPHYTA members like funaria and polytrichum, the sporophyte is distinguished into well-marked foot, theta, and capsule. So the capsule is made up of apophysis, theca, and leaves. That is the special characters of capsule. Okay, only we are observed in the BRYOPHYTA. Because of that, this is a well developed, evolved sporophyte. This is a complex structure. The capsule is made up of apophysis, theca, and a lid. But in the Markantia Anthoceras, these parts are not there in the capsule structure. Okay, remember this. I will tell you again and again. So in the capsule, it is made up of three parts: apophysis, theca, and lid. Okay, the food, theta, and the capsule. The apophysis of the capsule are all sterile parts of the sporophyte. From the evolutionary point of view, Funaria sporophyte has reached the most advanced stage. This is the Funaria. Okay, so peristomial teeth helps in the spore dispersal. Peristomial teeth are arranged in the epiphragm and at the peristome place. Okay, so in the theca, above the theca part, that operculum place, that the peristomial teeth are present. These are helps in the spore dispersal. Okay, see here. This is the Rixia, Carcinia, Targionia. This is the order now. Please remember this. This is all about the sporophyte's evolution. So first, coming to the Rixia, this is a very simple sporophyte. Foot, theta are absent. Coming to the Carcinia, just the foot is there, but theta is absent. Small foot and capsule is there. In the Targionia, capsule, foot, theta, and capsule. This is the Markantia. This is the Pellia. Pellia, we are observed that capsule wall is double layer, two-layered thickness, and elaters are coming together at one place. At the base of the capsule, elater of 4 is present in the Pellia sporophyte. This is Anthocera sporophyte. Foot and intercalary meristem or meristematic tissue, we are called. At the place of theta, instead of theta, intercalary meristem is there in the Anthocera. Please remember that. What is the special character? You remember. Okay, so wall layers, columella, pseudoelater. Anthoceras having the pseudoelater. Pellia elater 4, Markantia elater. Okay, for the elaters, for the spore dispersal, helps in the spore dispersal. This is about the Funaria sporophyte. Funaria and Polytrichum are same to same. Okay, so why? Because these two belongs to BRYOPHYTA members. But some structures, some differences are observed in the sporophytic structure. But capsule having the three parts, that is apophysis, theca, and lid part. Okay, operculum, peristomial teeth, epiphragm, diaphragm. So in the capsule center, that trabecula are present at the spores, mother cells, spore sac. Okay, so left side and air spare tissue is there. In the center, columella is there. This is the apophysis, and this is the fertile part is called theca. This is the lid part. Okay, this is about the progressive evolution of bryophyte. Ardhamainda emana? Are you understood?
Yes, ma'am.
So second one, what is that? Two theories are there for the evolution of bryophyte. That is the progressive theory. Next one is the second one, retrogressive evolution theory. Okay, this is also one of the theory. This theory was proposed with the oppositive view of progressive evolution theory. Okay, this is the opposite view. Because of that, that is the progressive. Opposite theory is retrogressive theory. Remember, very simple. This theory was proposed by Kashyap in the year 1919. Okay, so the progressive theory was proposed by Bauer in the year 1908 and supported by Cavers and Campbell, that progressive theory. But in the retrogressive theory was proposed by Kashyap in the year 1919 and supported by Church, Goebel and Evans. Okay, 3 member scientists, Church, Goebel and Evans. According to this theory, the evolution of sporophyte went from complex to simple forms. So in the progressive theory, what we observed? What is the way?
Complex.
Simple to complex. Very good. So same in this retrogressive, the evolution of sporophyte went from complex to simple forms. Okay, opposite view on matter. So from this complex stage, the simple stage evolved gradually. See here. So the important steps involved in this, see here. Only 3-4 points we are mentioned in the retrogressive theory, but the scientists are very important. Kashyap, okay? So retrogressive is given by Kashyap, proposed by Kashyap, supported by Church, Gobel and Evans. Please note down these names. Kashyap proposed the retrogressive theory in the year 1919 and supported by, tell me.
And these points I am writing in book, ma'am.
Okay. Main points you note down, okay? So it's given by Kashyap, supported by Church, Gobel and Evans. According to this theory, the evolution went to complex to simple form. Okay, see here the important steps involved in this are spore release and their dispersal mechanisms are reduced from specialized mechanisms to simple mechanical means. Okay, see here. So what in the retrogressive explains spore release and their dispersal mechanism. See here, I told you that in the sporophytic structure, polytrichum, funaria and anthoceras, the elaters, elaterophore and pseudo-elaters and peristomial teeth, operculum. These all are special structures we observed in the capsule structure. Okay, so those are for the releasing the helps in the spore releasing. So that's why that the spore release and their dispersal mechanisms all are reduced from the specialized mechanisms to simple mechanical, means sterile structures such as elaters, elaterophores are eliminated. Example, Rixia. Ikkada emaindi ante, so about this theory, according to this theory, retrogressive theory, that Kashyap told, what is that? That mechanisms all are no need. Okay, because of that all are sterile structures such as elaters, elaterophores, all are eliminated. Only that fertile part is there, spores are present in the capsule. That is the main thing. That's why this complex to simple. Example is Rixia. Chlorophyllous tissue in the capsule gradually decreased and finally disappeared. Rixia. So we are observed in the funaria, polytrichum, anthoceras. Chlorophyllous tissue is there in the capsule. So that chlorophyllous tissue also decreased and finally disappeared. That is the Rixia example. So no, chlorophyllous tissue is not there in the Rixia. Reduction in the capsule wall thickness to a single cell thickness. That's why the capsule wall thickness also reduced. Because of that, this is the only in the Rixia, only that fertile part is there. Furthermore, the sterile parts like the foot and seta are also eliminated, and the sporophyte only. Okay, sterile parts like that foot, seta are also eliminated. Consisted of the capsule. Example is the Rixia. ఇక్కడ ఏంటంటే మనకి retrogressive theory అంటే ఏంటి, కాంప్లెక్స్ టు సింపుల్ అని చెప్తున్నాం కదా. వాట్ ఈస్ ద సింపుల్ స్పెషాలిటీ అనేది ఇక్కడ ఇచ్చాం మనం. దాంతో మనకి మొత్తం retrogressive theory అనేది అర్థమవుతుంది. కాంప్లెక్స్ టు సింపుల్ కి ఎందుకు వచ్చింది? ఆల్ ఆర్ ద స్టెరైల్ స్ట్రక్చర్స్ సచ్ as elaters, elaterophores all are eliminated. Chlorophyllous tissue eliminated. Capsule wall thickness coming to the single cell thickness, and foot, seta are also eliminated. Only the sporophyte is there. That is the fertile part. That is more important. It consists of the capsule. Example is Rixia. This is about the retrogressive theory. This is complete evolution of the sporophyte in bryophyte. Okay. All are you understood these two theories?
Yes, ma'am.
Any doubt?
Okay. My dear friends, any doubts regarding of today's class? I hope Madam has clearly explained about the entire structures related to bryophyta, the evolution of the sporophyte, complete from progressive theory and retrogressive theory of evolution. So both the theories are most important. At the same time, the main features of the sporophyte, that means which part is most important, and for example Rixia, for example the Markantia, Anthoceras, Polytrichum, ఇలాంటి ఈ స్పోరోఫైట్ సిద్ధ బీజానికి సంబంధించినటువంటి పాదము కాడ గుళికలకు సంబంధించి 3 భాగాలు ఉన్నాయా లేదా, ఒకవేళ ఉన్నట్లయితే ఇఫ్ these 3 parts are consist the sporophyte, the major important points differences between the Anthoceras and sporophyte, Anthoceras sporophyte, at the same time the Polytrichum sporophyte difference we should learn. Why? Because Anthoceras sporophyte contains especially the vascular tissue. At the same time it is growing continuously till the death of the sporophyte. That means the sporophytic phase is completed. And also the sporophyte is depends upon the gametophyte in partial manner. So the sporophyte is a autotrophic nature. That is also most important. In sporophyte of the Polytrichum, we have observed the elaters. The elaters are we are observed in the Markantia. And Rixia sporophyte consists especially nerve cells. Anthoceras consists pseudoelaters, but the sporophyte of the Polytrichum does not possess of this nerve cells and elaters, pseudoelaters. But in that place, peristomial teeth are present. These are the comparative study among the different sporophytes of the bryophytes. So my dear friends, I hope madam has clearly explained today's class. And also I have already reminded you the archegonial structure. Archegonia means the ventral canal cells, number of ventral canal cells, number of lid cells, that is most important. And also in Polytrichum, you should observe the complex structure of the sporophyte, also most important. So madam has clearly explained from the beginning. That means general characteristic features of the BRYOPHYTA to the Markantia morphology and type study, morphology, anatomy, reproduction life cycle. Anthoceras, that means the Anthoceratopsida, that means hornwards life cycle, and Bryophyta, that means muci or mass plants life cycle. Madam has clearly explained in previous classes. I hope these classes are you are very well learned from our respected madam. Madam has clearly explained each and every point. So thank you very much, madam, regarding of your session. Our CPGET-2024 participants or aspirants, they are enjoyed your class and they are very happy to listen with full of attention and also patience. Thank you very much.
Sir.
I hope any doubt regarding of this class, my dear friends, Naina and Shailaja.
Sir, better
please.
than my college lecturers, madam is explaining, sir.
What about?
Better than my college lecturers, madam is explaining nicely, sir.
Yeah, that's why we are appreciate madam and congratulations madam, and we are wholeheartedly thankful to our Dr.A.SHAILAJA madam garu, because of she has huge experience, more than 16 years, 17 years experience. Madam has completed her PhD last I hope 10 years back. Is it right, madam?
Yes, sir.
Yeah, so that's why madam has huge experience in the plant sciences. We are very happy and we are very lucky. Am I right, Naina and Nitya, Nafis?
Yes, sir.
Okay, thank you very much, madam. These are the applause, these are the appreciation, these are the what the compliments, madam. We are very happy. Thank you very much, madam. మీరు ఒకసారి వీళ్ళ కనబడితే they are very happy. ఎక్కడ కనబడినా మిమ్మల్ని గుర్తు పెట్టుకుంటారు. ఎందుకంటే ఒక క్లాస్ చెప్పాలంటే అమ్మ, మై డియర్ ఫ్రెండ్స్, నైనా ఒక క్లాస్ మనం ఒక క్లాస్ వింటున్నామంటే మినిమం 4 to 5 అవర్స్ మేడం ప్రిపేర్ కావాల్సి ఉంటుంది. అంత టైం మనకు ఇస్తున్నారంటే ద కమిట్మెంట్ ఆఫ్ ది లెక్చరర్, ద కమిట్మెంట్ ఆఫ్ ది ఫ్యాకల్టీ మెంబర్, ఎంత స్టూడెంట్ కన్సర్న్ ఉందో మనం అర్థం చేసుకోవచ్చు. సో దట్స్ వై వీఆర్ వెరీ హ్యాపీ అండ్ థ్యాంక్ఫుల్ టు అవర్ మేడం. Is it right?
Sir, why that much time it takes, sir?
Why that much time prepare means each and every corner, each and every point we should cover in this class. Why? Because of this is not only an academic class. This academic class is very deeper from the competitive class. So competitive classes cover all the important points, all the corners. Each and every corner points also most important. So that's why madam has covered all the points. Am I right?
Yes, sir.
Okay, that's why madam, not only our madam, our entire CPGET faculty also, they are very experienced.
Sir, not
Among
only
that
Shailaja.
faculty members, Dr.A.SHAILAJA madam is very efficient personality.
Sir, not only Shailaja madam, and Manjula madam and
Kavita
another
madam.
madam also explaining very nicely, sir.
Yeah, that's why they are selected for your class, and also they are not only selected by ourselves, they are voluntarily accepted our request. They are voluntarily giving their services for our better future. So that's why better we should thankful to them forever, not only this time, not only tomorrow. మనం ఎప్పటికీ వీళ్ళకి థ్యాంక్ఫుల్ గా ఉండాలి, కృతజ్ఞత భావాన్ని చెప్పాల్సి ఉంటుంది, అంత టైం మనకి ఇవ్వడం. ఓకేనా? దీనికి సంబంధించిన అసైన్మెంట్స్ నేను పంపిస్తాను. ఒక పేపర్ ను కూడా నేను ఇప్పుడు రికార్డ్ చేస్తున్నా, అది మీకు యూట్యూబ్ లో పంపిస్తా, వినండి. గ్రూప్ లో ఉన్నారమ్మా మీరందరూ?
హలో నాయనా.
మ్యామ్.
ప్లస్ బాగా నైస్ ఎక్స్ప్లెనేషన్ అంటున్నారు. బట్ ఏంటంటే మీరు ఇవి ఏవైతే ఉన్నాయో మళ్ళీ రీకాల్ చేసుకొని ప్రతి క్లాస్ కూడా రివ్యూ చేసుకొని ఎగ్జామ్ బాగా రాసి మీరు మంచి ర్యాంక్స్ తెచ్చుకున్నప్పుడు ఇంకా మేము వెరీ హ్యాపీ, వి ఫీల్ వెరీ హ్యాపీ. ఓకే
మ్యామ్. ఓకే మ్యామ్.
ఎవరైతే ఉన్నారో క్లాసెస్ విన్న వాళ్ళందరూ కూడా చాలా బాగా ప్రిపేర్ అయ్యి ఎగ్జామ్స్ బాగా రాసి మంచి ర్యాంక్స్ తెచ్చుకున్నప్పుడు ఇంకా మేము హ్యాపీగా ఫీల్ అవుతాం.
ఓకే మ్యామ్.
సో
మీకోసం ఇంత టైం వేస్ట్ చేస్తున్నాము అని అనిపించదు. ఇంకా అప్పుడు మాకు ఆ ర్యాంక్స్ లలోనే ఆ హ్యాపీనెస్ అనేది కనబడాలన్నమాట. సో దట్స్ వై ఇష్టపడండి, మంచి ర్యాంక్స్ తెచ్చుకోండి.
our madams are expected from you unconditional positive. Our మేడం కు మన మీద ఉన్నటువంటిది భావన ఏంటంటే అన్కండిషనల్ పాజిటివ్ రిగార్డ్. మనం ఎక్కడ ఎప్పుడు ఏ స్థితిలో ఉన్నామో అనేటువంటిది కాకుండా ఇప్పుడు ఈ రోజు రేపటి మీ భవిష్యత్తులో ఏం కావాలనేటువంటి ఒక సదుద్దేశంతో మేడం లాంటి వాళ్ళు మన శైలజ మేడంతో పాటు మిగతా మేడమ్స్ ఉన్నారు. దీన్ని మనం ఏమని చెప్పుకోవచ్చు అంటే మన మీద వాళ్ళకు ఉన్నటువంటి అన్కండిషనల్ పాజిటివ్ రిగార్డ్ అంటారు. దీన్ని సైకాలజికల్ టర్మ్ ఇది. అన్కండిషనల్ పాజిటివ్ రిగార్డ్ అంటే ఎలాంటి ఆశించకుండా, మన నుంచి ఎలాంటి ఆశించకుండా కేవలం మీరు బాగుండాలి అనే ఒక మంచి ఆశించేటువంటి విధానం అన్నమాట. మీరు ఎక్కడైనా మంచి పొజిషన్లో ఉండాలి. ఇప్పుడు మేడం గారు చెప్పిన మా విషయం ఏంటంటే రేపు పీజీ ఎంట్రన్స్ లో మెరిటోరియస్ ర్యాంక్ సాధించి మీరు టాప్ మోస్ట్ లో ఉండి పీజీ పూర్తి చేసుకొని రేపు ఎమర్జింగ్ బాటనిస్ట్ గా సొసైటీలో మీరు ఎదగాలి. ఓకే
ఓకే సార్. సార్ ఇంత మంచిగా మా కాలేజ్ లో కూడా ఎక్స్ప్లెయిన్ చేయలేదు సార్, అంత మంచిగా ఎక్స్ప్లెయిన్ చేస్తారు మీరు.
నేను అడగలేను ఇంతకు, అసలు నేను ఇది రికార్డింగ్ ఆపేస్తాను. మీ కాలేజ్ ఏంటి దాని తర్వాత అడుగుతాను. ఒక్క నిమిషం. మీరు ఒకసారి దాన్ని ఏమంటాం, ఈ వీడియో ఆన్ చేసుకొని చూడండి, అప్పుడు మీరు కనబడతారు. మీరు వీడియో ఆన్ చేసుకొని చూస్తే కనబడతారు, లేకపోతే కనబడరు. కనబడలే. ఇప్పుడు మీరు అట్లా భయపడితే మేము ఏం చేయాలమ్మా? ఓకే, వెరీ గుడ్. అయితే నేనేమంటున్నానంటే మేము మిమ్మల్ని ఐడెంటిటీ ఇట్లా చూపించినా మేము ఒక్కసారి చూస్తే మాకు ఏం గుర్తుంటుంది మనకాడ, కానీ మీరు సక్సెస్ కాండి అంతే. ఓకే, మీరు ఎక్కడ సక్సెస్ అయినా మాకు చాలా హ్యాపీ.
సార్ డెఫినెట్లీ సార్.
Okay, Nitya and Nafis, Maryam, Mahavin, thank you very much. Madam, shall we wind up the session?
Okay, sir. Okay.
Right, madam. Thank you.